Good day, everyone. I'd like to welcome you to a presentation by Syndicate 22, a future SASL through digital transformation. But first, let me introduce you to SYN 22. SYN 22 is Khomotso, Mogobodile, Merle, Natalie, Leslie, Mapule, Tandiwe, and Shireen. We are a group of individuals who are all passionate about adding value to organizations through digital technologies and solutions. In this presentation, we hope to do the same for SASL. Today's presentation will include a quick background which covers our understanding of SASL. We will move into some specific challenges that we as a team have observed and what the impact of those challenges might be. And then we will present our proposed solution. We will cover the benefits of that solution, show some examples of where this has worked, and then we'll talk a bit about how this can be implemented within SASL. So let's get started. SASL, the South African Coal, Oil and Gas Corporation, founded in 1950, was established during the process of industrialization that the South African government considered essential for both its economic development as well as its autonomy. It is now a global chemicals and energy company, listed on both the JSE and the New York Stock Exchange, sourcing, producing, and marketing high-quality products in 23 countries. SASL's purpose, innovating for a better world, describes their reason for being, answers the question, why does SASL exist? It captures the essence of a future SASL and supports their triple bottom line outcomes, where SASL is committed to ensuring that they provide a safe work environment for their people, where they aim to maximize value creation that is clearly defined through financial targets, and decarbonizing, which is essential to SASL's sustainability and core to them transitioning to a future SASL. And now I'd like to hand over to my colleague Merle. Thank you.
Thank you, Shireen. My name is Melly, and I'll be continuing from the problem statement. The current process of generating and issuing work permit for contractors at SASL is a process that we believe as a team is time-wasting, costly, and also exposing the people that are involved in the process under the risk of getting COVID-19. Currently, SASL Secunda, for example, is dealing with plus or minus 40 different contractors at a time. And each and every contractor has got a team that they work with. According to SASL's policies, none of the contractors are allowed to go and work on-site without a work permit. A work permit is generated by SASL's permit generating officer. In the next slide, I'm going to take you through the process of generating the permit. Let me take you through the process of generating and issuing out permits to contractors. But before I do that, I want you to take note of the following. This process is what we have identified as the challenge that SASL is facing. The second thing is that the person responsible for generating and issuing out these permits has got other duties and responsibilities that he's expected to fulfill. The last thing that I want you to take note is that every single process that I'm going to show you here, he is expected to repeat it for each and every permit that needs to be issued out, even if the permit that he's working on is similar or works under the same conditions as the previous one. The process is as follows. The permit generating officer generates a template from Eclipse system. From thereafter, he manually types every section that is left open from section 1 up until section 9. When he finishes doing that, he prints out the permits, signs them, and thereafter makes them available for the contractor to go and share with their team. Now, imagine a situation whereby this officer now has to deal with plus or minus 15 contractors that have got 17 people in each and every time. He has to repeat this process for each and every person that needs to receive a permit. This is just an example of the sections that he needs to complete on the permit from section 1 up until section 9. The most interesting thing that I want to highlight on this process is that over and above completing all the sections that I've mentioned, the permit generating officer still needs to also deal with the same permit after the contractor has worked on site. He has to check as to whether if they have complied with all the regulations that have been stated and also close out the whole process and reason behind issuing out this permit. Now I'm going to hand over to Leslie to continue with the rest of the part.
On the next slide, I'm going to take you through the impact caused by manual work permit process. Only one permit can be generated and issued at a time, which is a time-consuming process. Manual typing and data capturing of information on the computer-based system increases the chance of human error. The high volumes of admin work generated can be costly, as headcounts needs to be increased for the admin processing performed. Contractors waiting to be assessed by relatively slow process can increase the traffic at a permit office, which can compromise the health and safety. And with the advent of COVID-19, this can potentiate the spread of this disease. Next, I will hand you over to Tandy to explain how we will solve these challenges.
Thank you very much, Leslie. Now let us delve a little into what the proposed solution is. SYN22 Digital Permits is a mobile application and web portal that manages the permit to work process through a digital database that records and facilitates work permits. How does SYN22 Digital Permits work? The contractor logs onto the system via the app and submits a request for a permit. The system checks the information completed on the digital form against the database of contractors and work orders. The request is sent to the permit officer for approval via an automated workflow, and they are notified via email or via an alert on the dedicated app. Once approved, the permit is issued to the contractor and the contractor is notified of the authorization via an alert on their app, and they can proceed to go to the plant. At the plant, all authorized people will be granted access at the security checking station by activating fingerprints or smart cards for the duration of time stipulated on the permit. All permits that have been granted can be accessed on a dedicated dashboard. Stored information can be used to reissue, extend, or terminate permits. Detailed analytics can be done from the data to monitor access, generate incident reports, and identify any safety issues. The stored data can further be used for the planning and scheduling of plant access. Thank you. Now I would like to hand over to my colleague Mapule, who will explain the look, feel, and functionality of the app.
Looking at the design of the web portal or application, the design is one which is simple and user-friendly. It is seamless and straight to the point. The supervisor from within SASL and the contracting supervisor have access to the portal. They can register to be a part of the admin, and also upon completion of registration, they are able to log in using a username and a password. Upon completion of the registration and successful logging in, they'll land on the dashboard. The dashboard screen allows them to edit an existing permit and also create a new permit. When you create a new permit, you will land on the employee work permit form, which you fill in with details of every contractor who will be working on the project. Details such as the name, their cell phone, ID number, the date of employment, type of working environment, and also the place of working environment, also enabling access when registering at the gate for the permits so that they know where to give access to the employee. And then also they get to have the employee sign, and also the contractor, and also then the supervisor will sign to give authorization and submit the form if it is successful. And then once the form is submitted, you land on the success screen, which then shows that the permit was saved and the permit now is successful and captured, and now the contractor is able to gain access. Then here is a demo of how it works. Thank you. Over to Tandiwe.
Thank you, Mapule. Now that we've seen the demo, let's turn our attention to fourth industrial revolution technologies that underpin SIN22 digital labs. SIN22 end-user applications are hosted on a public cloud, allowing for secure data storage, on-demand self-service with remote access. But most importantly, the integration of metered and auto-elasticity features, providing varied and on-demand computer power, or pay-as-you-go, if you will. SIN22 digital permits also uses big data analytics and can monitor access to Sasol plants in real time, report incidents, and in turn give management the opportunity to swiftly mitigate risks. In this day and age, seamless and secure access into business premises for any organization is of the utmost importance and priority. SIN22 digital permits uses state-of-the-art biometric and smart card technology to grant contractors access to designated areas. Always remember, Big Brother is always watching. We know who you are, where you are, and what you're doing. And finally, automated planning. This is an artificial intelligence feature integrated into SIN22's digital permits ecosystem. Its main purpose is to schedule contractor access efficiently and thus dramatically reducing manual scheduling processes. I will now hand over to my colleague Homotso.
I will be discussing the benefits as well as the case studies. With regards to the benefits of the solution, SIN22 Digital will minimize a manual work like admin, and this can tend to have a cost-effective and less time spent. SIN22 Digital, it will be centralized and it has a range of capabilities. Because we're going digital, we're now environmental friendly and there will be less printing. The system will have an impact in reducing the number of people in the permit access office, and that can even eliminate other risks. SIN22 Digital will have more accurate recording, reducing human error, and it will be highly supervised, creating an improved planning and scheduling and better controlled access. Now let's look at the case study. The case study that we'll be discussing will be the Pisces customer. The Pisces customer is a well-known Japanese engineering firm, introduced a cloud-based permit to a work system on a 985.7 million construction project of a new fertilizer plant in Caspian region, which managed remotely from Japan. Their task was looking for a robust, simple to use, and introduce electronic system that could cope with a large volume of permits, support 8 different permit types, and support a complex of permit workflow and multi-signature approved process. Well, their successful story was that the team managed to create more than 1,000 permits each month, 15 detailed plot plans which can be viewed by all teams everywhere, show permits as colored dots in their location, better understanding of permits and safety plans, and a defined approval workflow for each type of permit which is enforced by the system. A fewer hold-ups caused by the missing approvals as people are notified automatically by emails or SMS. A safer working on a complex project while adhering to international standards. I will then hand over to Natalie.
Thank you, Khomoto. We are now going to look at how the project will be implemented and what is required to achieve that. We will first look at the rollout plan. The project will be run in 4 phases. Phase A is where research and resource securing will take place. Regular stakeholder engagement is crucial at this stage as we need to ensure that we have buy-in from all the relevant stakeholders. This should take 3 weeks. Phase B will focus on the design and development of the app. This is estimated to take 6 weeks. The testing of the app will take place in Phase C. User accepting testing will be done where a sample of permit officers will test if the app and proposed new system works. The estimated duration of all of this is 2 weeks. The app will be launched in Phase D where it will be available for all users. Now that we have a rollout plan, we now need to see how much all of this will cost. The budget plan is broken down into 3 sections: the initiation phase, execution phase, and monitoring and control. At the initiation phase, 1,660,000 is required for research, design and development, and marketing. At the execution phase, 320,000 will be required for launch and training. 1,550,000 needs to be set aside for the continuous development of the app, cloud services, and the staff required to support the smooth running of the app. The total project cost is estimated at 3,530,000. Now that we know how much is needed, the funding chat comes in. We have 2 proposed funding options. Option A is the project being fully funded by Sasol. Sasol will own all copyrights to the project. Option B is where we use the asset sharing model by offering Sasol a 15% discount in exchange for access to the data collected during this project for a limited time period. This brings us to the end of our presentation. Thank you very much for your time.